see how this all goes. So do we want to talk about any of those problems? You guys got pretty far on your homework, not to the end, but do you want to talk about any of them? Ask questions. If I give you 2 points right now, can you give me the slope between those 2 points? Yeah? Can you be able to do it? You're going to consistently pull the y's out and put those up top, and consistently pull out the x's and put those on the bottom in the right order? Yeah? For sure, for sure? So, any questions that we should answer? Ladies? Don't worry about this. This is Algebra 2. Any? You said you did them all? Oh, the percent ones? Okay. Yeah, so the first one they say it's 16 out of 64. And they want to know what percent 16 out of 64 is. His glasses are on the floor, or keeps his glasses. So if it's 16 out of, we would write it as this, 16 out of a total of 64. Just like when you do a half, that's 1 out of 2. So I think what they wanted us to be able to see with this, I mean, ultimately they want you to see that 4 times 16 is 64. And there's lots of ways to look at that. If you can do 16 and 16 in your head, 16 plus 16 is 32. And 32 plus 32 is 64. So ultimately, if you can see that in your head, 16 plus 16, that's 32, that's 32, so the whole thing's 64, therefore we have a fourth of the circle. Or maybe you gotta go to paper, and you gotta do this, and you got, okay, maybe there you see that 4 times 8 is 32, so this is 1/4. Or maybe you gotta change it to 4 over 16, because what you're doing is dividing the top and the bottom by 2. Divide the top and the bottom by 2 again. Do it again, and then you have 2 over 8, and you do it again, and you have 1 over 4. And we're supposed to know at this stage of the game that 1/4 is the same as 25% without having to do the long work with that. As if you have 25%, that's a fourth. Here's another fourth. Do that 4 times. So that's what they wanted us to see with the letter A. Letter B, wasn't that like 70% of something or 80% of something? What was it? What does 22B ask? Okay, 75% of 80, and we gotta find out what the number is. So yeah, last year we taught you how to do this point. You change this either to a fraction or a decimal, and you multiply it by 80. If you change it to a fraction, that's the same as 3/4 multiplied by 80. But they want us to do this one in our head because this is one of those commonly used percents, like 10% or 25%. This is a multiple of 25s. So if this is 3/4 of 80 in our head, we can think of 80 being divided up 4 ways. So this is 40, that's 40. 20 and 20 is 40. 20 and 20 is 40 again. And 3/4 of that would be 3 of these, so that's got to be 60. That's the thinking that they wanted us to go through. So were there any other questions you would like to ask? Any? Mars? Leo? No? Great. it? So we go ahead. Okay. Can you tell me what the equation is for slope? M equals?
y2 minus y1 over x2 minus x1.
Good. And the next one is lesson 3, properties of slope. Your dad builds, doesn't he?
Oh, he used to.
He
He still
used to?
does some stuff on our house.
Well, lots of people build. Wish we were over in the other room, because we could look at all the different roofs that are outside. Remember the church?
Yeah.
Across the way, how steep it is? And then if you look over at, where the totem is, that house that's on the corner, she doesn't have such a steep roof. I can't remember her name. I think Kylie was her niece or granddaughter, something like that. But they have the roofs have a different pitch to them. They call it pitch when they build a roof. But it's slope. They have different slope. And actually the church is like this. It's like a 45-degree angle. It's like so. So what they call that is a 12-12 roof, which means the rise and the run are 12 and 12. So in other words, if you were standing on this roof, you'd have to go up 12 and go over 12 inches to get your foot back on the roof. And you go up 12 and you go over 12 again, then you get back on the roof like that. So that's a 12-12 pitch. But what would be the slope of that? What would be the slope if you had a rise of 12 and a run of 12? 1. So it would be a 1. Yeah. And then other roofs, it's kind of like this. You go up 4 inches and then you go back over 12 inches and you end up back on the roof. So it's like steps, up 4 and over 12, up 4 and over 12. So that's a rise of 4 and a run of 12. So what's that slope? What does that simplify into? 1 over 3. And this is called a 412 roof. So instead of going up 4 and over 12, you could go up 1 and over 3. You could take smaller steps. Or you could take bigger steps. If you went up 8, how far would you have to go over to end up back on the roof? How much? You have to go over 24. But all that would simplify to this right here. All of this simplifies to 1 over 1. So you could take little steps, up an inch, up an inch, up and over, up and over, up and over 1 inch. That would be the same. You'd stay on the roof. So you can look at big long runs of a line, or you can look at short runs along a line to determine what the slope is. Here's what I've learned since I moved to Alaska. Snow will slide off of that. But if you build a roof like this, where you go up 5 and over 12, up 5 and over 12, it'll slide way easier. Very, very quickly. This, gosh, it slides in the middle of a snowstorm. You cannot stand on that. Your feet won't stick. It's impossible to stand on it. If you do a, let's see, how does it go here? A 612, what would be the slope of a 612 roof? That would be 1/2. You can stand on that, but it's a little spooky. You can stand on it. Walking on it is like, ooh, you gotta be careful. And then they say that you can stand on that on an 812. That's the steepest roof you can stand on. So what's the slope of an 812? Two-thirds. Yeah, so it's twice as steep as a 412. So that's roots. Roots are slopes. So if you knew, go back to the math end of this. If you knew that you had a line, and that line was going to go through, I'd rather do this over here actually, so I can have a little graph. If you had a line and you knew that that line was going to go through a certain point, like they said, well, the line is going to go through the point 2, 3. And the slope of the line is going to be something like a slope of 3. Could you draw the line on the graph? Let's see how this goes. Let's see if this works, if they'll be able to see it. I'm going to put my different axes on here. So let's just do this right here. How much of it can you see? Not very much, huh? Let me see if we zoom out as far as we can. There it is. Okay, so there's my y-axis and here's my x-axis. So what did I say? 2, 3. If that's the point right there, 2, 3. And we want to have a line that has a slope of 3. Could you put the line on that graph now? Is that enough information? No? The point 2, 3 is on the line. It could be going any direction. If it's a slope of 3, is it going up or is it going down as you look across the graph? So is it going to be a line that's going to be like this? It's going to be a line like that. Yeah, it's going to be like this. It's going to be increasing because it's a positive slope. So with a slope of 3, what's the rise? 1 or 3? Here, write it as a fraction. How do you write the number 3 as a fraction? 3 over 1. So this is your rise, and that's your run. So if that's my point right there, 2, 3, and the line goes through here, all we have to think about is, well, if it goes through that, it's not going to be this kind of a line because that's a decreasing slope. It's going to be something like this. And we just have to make sure that when we travel along the line, we go up 3 and over 1 to get to the next point. So you go up 3, you go over 1, you're back on the line. You go up 3, you come back over 1, you're back on the line. Oops. So this is plus 3, that's plus 1. Rise of 3, run of 1. And then likewise, I can go down 3 if I go to the left 1, because those fractions are equal. So if I go down 3 and back 1, here I am back on the line again. Down 3 and back 1. So here's a whole bunch of points. They all fall in a line. There's the line of the equation that has a slope of 3, and it goes through the point 2, 3. Do another one. Go to the point -4, 5. And then drawing a line that has a slope of -2. So if you're given that much information, what do you have to go through to get it done? Step 1. What's that? Put the point on. So from the origin, which direction do I go? If I count from here, where do I have to go to get to that point? Left 4. And then? Up 5. Okay, so there's one point. It's on the line. Where's the next point that I have to put out?
4 more to the left from that last point.
Go where?
4 to the left.
4 to the left, did you say?
Then up 5.
Oh, and then up 5. Well, if I went 4 to the left and up 5, then I would be doing a slope of 5 over negative 4. I want to have a slope of negative 2. So that is not what I want to do. Yeah, think of this as negative 2 over 1. So I can go down 2 and over 1. There's another point on my line. Down 2 and over 1. Down 2 and over 1. So there would be a line that has a slope of negative 2 that goes through the point negative 4 or 5. So one of the properties of the slope is that there's a constant rise and run from point to point as we travel along the line. Let's see. Let's just keep going with this idea while we're on here. And I'm gonna go for another color. This might be important for you to have written down. So now what I'd like to do is I would like to just draw a line with a slope of 0. And let's go through that same point, negative 4, 5. So let's use this point. So we've got what, negative 4, 5, there it is. How are you going to find another point on a line that would have a slope of 0? Do what? Just go straight across. Yeah, because the higher the greater the slope, the steeper the line. So in this case here, we can write 0 as 0 over any number at all. It doesn't matter what, as long as it's not 0. So you have a rise of 0, and the run could be 1 to the right. It could be many to the right. It could be to the left. So what we're saying here is that the rise is nothing. So when we have a slope of 0, that's going to be a horizontal line. Okay, here's another line for you. We'll put the line out, and then the question is, what do you think the slope is? So this red line, it's a vertical line. What do you think the slope would be? So think about it, you go from point to point along the line. You go point to point along this line. What's the rise? Remember, slope is rise over run. So what's the rise from one point to the next? Could you have a rise of 1 and stay on the line? Could you have a rise of 5? So the rise can be anything. It can be any number you want it to be. What's the run? It's 0. Yeah, you're not going left and right. So when we write this, well, I'm back to blue again, but anyway, the slope as a rise over run can be any value divided by 0. But when we divide by 0, that's undefined. So we say that this is an undefined slope. So the slope is undefined for all vertical lines. There is no slope. It can't be quantified. So that gets us to this whole idea of what is undefined. See, you can't take like a rise of 5 divided by 0 and make that into a value. And you can't take 10 divided by 0 and make that into a value. So we have to say it's undefined. If we look at this and we think of it as change that's happening as we go left and right, there is no change that happens. So what's happening here, what we're interpreting is that at the same point, there's 2 different answers or 2 different numbers that you can come up with. And you know in math, it doesn't make sense to have 2 different answers to the same problem. It shouldn't work that way. It should be that you have a single answer. And that's what this vertical line is about. We'll talk about it more later on when we compare it to different functions and such. But all vertical lines are undefined slope. All horizontal lines are a slope of 0. That's a part of this lesson. The last thing is there's an example that they give us, example number 2. And they talk about stacking chairs. And I think what I'll do is I'll just put it underneath the doc cam and we can kind of discuss what they have here rather than go through the whole motion. This is on page 343. And so they give an example. A certain stacking chair is 31 inches tall. In a stack, each chair adds 4 inches to the height of the stack. So you think about the black chairs that are in most of the rooms, you know how they stack up? The first one is this high, and then the next one slides into it, so it only goes up a couple inches. So if you have a stack of 1 chair, here they're saying it's 31 inches tall. And if you stack 2 chairs, because of how they slide together, now it's going to be a total of 31 plus 4 inches tall. So what they did is they put that together in a graph. And so they say 1 chair is 31 inches tall, 2 chairs is 35 inches, 3 chairs is 39 inches, and so on. And they do not connect the points with a line because there's no such thing as a half chair when you stack them. You either stack the chair or you don't stack the chair. So you wouldn't want to connect these points. There's no in-between here. These are called discrete points or discrete values. So just remember, whenever we graph, if we're graphing things that we count, like chairs or apples or oranges or something like that, then we just use points. We don't connect the points. But there's still like a rate of change. There's still a slope that goes along with this. So as you move over for each chair, how much does this increase by? How many inches? Each chair adds how many inches to the height of the stack? 4 inches. So we can think of this as having a slope of 4. And they've got some information here which I can show you about the equation. And this is a new way of looking at equations. But what they say is the height is equal to the starting height, which is 31 inches. And then to that, we add 4 inches for every single chair, so the number of chairs. But the problem is, so you might think of it like this. Well, it's 4 inches times the number of chairs. But if you have 1 chair, it's only 31 inches tall. So we can't say it's 4 inches times the number of chairs. We have to eliminate that first chair. Because that doesn't add 4 inches, that gives us our stubbing height. So what we do here is we say 4 times the number of chairs, subtract that first chair. And then this is the equation of that line. So that line started out at 1 chair at 31 inches high. And then it went to 2 chairs, which was 4 inches higher. So this change here is 4. But we're starting at 1 chair, we're not starting at 0 chairs. So this number here is when you have just 1 chair, but you would think of it as being at 0 additional chairs. So it's a little bit different way of looking at equations. This is one of the ways that we write sequences. And when we count objects and we graph them, we oftentimes will graph them as a sequence. And we did some of that earlier in the year last year. Actually, the year before in 7th grade, when we were looking at blue and orange colored boxes that were arranged in rectangles. And we'll come back to that in the near future, and we'll look at the difference between different types of equations. So, with that should be enough to get you started on your work. Page 344. You want me to read them?
I got it.
You got them? You guys want some graph paper, some sticky graph paper?